Today we are going to be demonstrating the capabilities of two pieces of hardware. The first being a Raspberry Pi and the second being an RTL-SDR, or a software-defined radio. So a Raspberry Pi is a single board computer originally manufactured with the intention of teaching basic computer science skills in schools and developing countries. In more recent times, it has gained popularity with hobbyists because of its very simple design and infinite number of uses. And the next piece of hardware, the RTL-SDR, is a software-defined radio. So the original use of these devices were as digital video broadcasting USB dongles, and a man by the name of Eric Fry discovered that they can be repurposed as wideband radio receivers. So what we're going to need today is an RTL SDR kit. You can find them on Amazon for about $30, and they come with like the basic antennas and everything you would need. Next thing you're going to need is a Raspberry Pi. In this demonstration, I'm going to be using a Raspberry Pi 2. You can use whichever one you would like. Onboard Wi-Fi isn't necessary, although later on you may want to use a Wi-Fi dongle with it. Third thing you're going to need is a computer. Fourth thing is a car. The fifth thing is a bit of common sense. And the sixth thing is basic command line knowledge. Before we get into our demonstration here, let's talk a little bit about the radio spectrum. So here is a PDF provided by the FCC of the frequency allocations in the United States. So this is about where radio signals are allocated to. So you can see we're starting at 0 kilohertz here, moving up through all of this, and we get to something familiar here. Here is going to be AM radio. So pretty much from 535 kilohertz to roughly 1605 kilohertz. Now when you turn on AM radio in your car, this is the part of the spectrum that's being transmitted in. And so it goes all the way up to 300 gigahertz here. And you can see around the 300, 400, 500 megahertz range, we get into more familiar stuff, television broadcasting, things like that. Pretty much above that range, it gets really messy. And there's a lot of stuff in there that we're not going to be dealing with. So another important note is these green sections here that are labeled amateur. Here, 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 and some high frequency up here. So in order to transmit in those bands, you need to take an exam and have a license to transmit in those bands. You need to be certified. Now, even if you're certified in the amateur bands, that does not mean you can just transmit wherever you'd like. That is a big no-no. That's illegal. Now, if you don't have any proper licensing, you cannot even transmit in the amateur bands. You're essentially confined to a very, very small area over here or here. That's basically the frequency that a Walmart walkie-talkie works on. So for you to be unlicensed transmitting outside of those bands is against the law, and there's whatever punishment for that. So if you want to operate with disregard for the law, go for it. We're going to be safe today, and we are fully licensed, so we have nothing to worry about. The part of the spectrum we're going to be working in is around the 300 megahertz range. Now we're going to be dealing with car keys, and most car keys operate around 315 megahertz, so we'll be right in the mobile band. Now, That's outside of the amateur bands, but your car key is an FCC licensed device, so obviously it's not illegal to operate your car key. So use common sense. Don't dump all over the spectrum where you're not supposed to be, especially in some of these sensitive areas such as air frequencies, emergency frequencies, or military frequencies. Next, we're going to talk about what we are going to be doing today. We're going to be performing a replay attack on your own car. Nobody else's car, but your own. Otherwise, that would be against the law. So, here is an image I've stolen from Wikipedia that details the basics of what a replay attack is. So here's person A, here's person B, here's person E, a third party. Person A is sending their hash password to person B to log in or perform a certain function. Person E is a third party. They are listening in on the transmission of that password from person A to person B. At a later time, what person E will do is they will replay that recorded transmission to person B in order to perform the function that person A did. But even though person E is not authorized to perform that. So in the sense of cars, the way this works is here's you with your car's key fob remote. Person B is your car, and person E is a third party. You press the button to unlock your car, which is your password. It goes to the car. The car accepts that password. Simultaneously, while you're doing that, person E is recording that radio transmission. They will replay that back at a later date in order to unlock your car when you, person A, are not present. So that's the basic rundown of how it works. It gets a little bit more complicated when you talk about newer cars and rolling codes and keyless entry and things like that, but we will get into that in a bit here. So the first thing that you're going to want to do is you have your SD card, you have your Raspberry Pi. You have to use an etcher or an imager in order to install a Raspbian on your device. So we use Raspberry Pi Imager, and we can open that up. You're going to choose your SD card here, and when you choose your OS, this is going to be the most common one with the desktop environment. We don't want that one as it's a lot slower, and we're not going to be making use of the actual desktop interface. So for that, we're going to go to Other, and then you're going to want to install Raspberry Pi OS Lite with no desktop environment. We don't need the desktop environment because we're going to be doing everything from the command line today. So once you have that installed, you can come back, and you should have SSH set up already, and your Raspberry Pi either plugged into your Ethernet port on your router or logged into your Wi-Fi. So after you've done that, you're going to open up a terminal session here, and you're going to SSH into your Raspberry Pi, and you're going to do that by simply going SSH pi at raspberrypi.lan. Yours may be different. Yours may be .local, or Raspberry Pi may be just your Raspberry Pi's IP address. And if that's the case, you will have to use some other network tool to locate that. And yes, we want to connect, and the password is probably going to be your default Raspberry. And so now we are SSH'd into our Raspberry Pi. And the first thing you're going to want to do is you're going to want to make sure everything is up to date. And you're going to do that by going sudo apt-get update. And so I already have everything installed and everything up to date, so I will just fast forward through this process. All right, once that has completed, you're also going to need some dependencies. First one, most importantly, is going to be git, so you're going to do that with the same command, sudo apt get install git, enter. So we already have it installed, obviously, so we don't need to install it again. After that, you're going to need to clone a Git repo where a program called RPITX is located. Now, RPITX is RPI, Raspberry Pi. TX is transmission. So you're going to do that by going git clone github.com/f50eo/RPITX. Now it already exists and I already have the files there, which is why we're getting that warning. Next you have to install it. So you're going to want to cd into the RPITX directory. Cd RPITX. And now that we're in there, you're going to want to issue the command /install.sh. So we've already installed it again, so we can just wait for this to complete. All right, so prior to installing the RTL-SDR software on the Raspberry Pi, a lot of other information goes over the fact that you sometimes need to install the cmake command on your Raspberry Pi, and you can do this by doing the same thing: sudo apt get install cmake. Again, I already have it, so we don't need it again. After that, we're going to want to clone a second GitHub repo. So you can go back to your home directory and go git clone github.com/KENERD/RTL-SDR and hit return. Now I already have it again, so then you're going to want to cd into that directory, RTL-SDR, and now that we're there, you have to issue the build command to build the application yourself. So you're going to do that by going mkdir build. Now I already have it again, so we don't need to worry about that. After that, you can cd into the build directory, and you're going to issue the cmake command as follows: cmake space // hyphen deinstall _udev_rules equals on. And so you would issue that command, and I do not have to do it as I already have it. After that, you're just going to issue the make command. And so we've just built the application in that directory. Following this, you have to install it. So you're going to do sudo make install. And after that, you're going to go sudo ld-config, and then cd back into your home directory. Another thing that is also skipped over frequently is you need extra software or drivers in order for your Raspberry Pi to be able to interface with your SDR. So that's going to be libusb. Now you can't just use the common version of libusb, you have to use the developer version that includes all the libraries. So you're going to issue the command sudo apt get install libusb -1.0 -0 -dev. Return. So we already have that. Next, you're going to want to cd into your home directory. So what we're going to do is you need some sort of SDR software in order to be able to interface with your SDR from your computer. So on Mac, it's going to be you can use GQRX, and you can install that via the terminal on your computer using Homebrew, or you can just download Cubic SDR. So we have Cubic SDR here. It's going to pop up with this, and you're just going to want to select your RTL-SDR from that list and click Start. Now, for this part, you do need your car keys. And we know that most car keys operate in the 300 megahertz range. But you can double check this and make it easier by looking on the back of your key fob. It's going to say FCC ID followed by a string of letters and numbers. You can go to Google and type in FCC ID lookup, paste in those numbers off of the back of your key fob, and it will tell you the exact frequency or the range of frequencies that your car key fob operates on. So I've already done that. I know mine is around 315. So we can just click here. So now we're listening to empty spectrum. What we're going to want to do in order to identify exactly where the exact frequency where the car key is transmitting is you're going to want to press the button. So as you can see, I've just pressed the button a few times there. So I know it's over here. So you're going to want to move that so it's in the center of that transmission, and you're going to want to switch to narrowband FM. And you're really going to want to zoom in here and make sure that the whole signal is covered and that you're in the center of the transmission. So that looks about good to me right there. And we don't do the actual recording in here. We're going to make note of this frequency. So in my case, it's 314.871. So we're done with Cubic SDR for now. So you can close out of that. You're going to want to go back to your Raspberry Pi here. And you're going to want to plug in your SDR into your Raspberry Pi's USB port. So I'm going to do that, and I will be right back. So now that you've plugged your SDR into your Raspberry Pi, you're going to want to jump back into that SSH session and cd into the RPITX directory. From there, we're going to issue the following command using the RTL-SDR software that is installed on the Raspberry Pi. And this command is going to enable us to record the transmission that your key fob makes. So the command is as follows: RTL_SDR space -S 250000 space -G for the gain. You can set this to whatever works for you. In my case, I find that a gain of 35 is perfectly fine. Space -F for your frequency. You're going to enter the frequency that you've made note of without the period in it. So -F space, and in my case it's going to be 314.871. And after that you're going to go space again, and the next part is going to be what you want to name the file. So it can be pretty much anything you want. In my case, I'm going to name it unlockcar.iq. Just make sure you have the IQ after that. So once we hit return, it will process the command, and at that point it will begin recording from the Raspberry Pi. At that point, you're going to want to grab your car keys and press the unlock button a few times. And then once you've pressed the unlock button a few times, you are going to press Control-C to quit the process. So it works just like this. I'm going to hit return. It loads in. I'm going to click the unlock button a few times. And then I'm going to hit Control-C. You can see we've caught the signal successfully and we've exited. And you can check if this was successful by just doing ls, and you can see unlockcar.iq is right there. So now that we've recorded the signal of the car, we have to play it back. Now, something that I forgot to mention was relating to rolling codes. If you have a car manufactured in the past, 20 to 30 years, odds are is it uses a rolling code. And what that means is that every time you are in range of the car and you press the unlock button and the car acknowledges that the unlock button has been pressed, that code is burned. So these codes are generated based on a mathematical algorithm, and the key fob knows which code it's distributing, and that syncs with the car, and the car knows which code to expect. So if you are walking to your car, if you're in range of your car and you press the unlock button and it is recorded and you try to replay that back, it will not work because that code has been burned already. So there are two methods to get around this. The first one is you could construct a radio frequency jammer, and you could jam the signal of, in this case, 314 megahertz to prevent your key fob, to prevent the signal from the key fob ever reaching the car, so the code would not be burned. Now, you should not do this, as that is a federal crime to jam radio signals, and we try to stay away from those if at all possible. The second option is the easiest, is you're just going to make sure that your car cannot hear the signal that you're broadcasting. So you're just going to want to go out of range where the car is not able to acknowledge that the signal has been received. So you can do that by just going a decent distance away. It's very easy. So what we're going to do now is you need to replay this back, and you need to be, when you replay it, it's going to be replayed from your Raspberry Pi. Now, you have to be in range of your car. Odds are your car is not next to your computer. So you will have to either leave your Raspberry Pi connected where it is currently inside of your house and still have SSH access when you go outside, or you can bring your Raspberry Pi with you and SSH from your phone or laptop, as the Raspberry Pi is connected to a battery bank or via USB, and you can replay the signal that way. I would recommend, if possible, using a Wi-Fi dongle or bringing it actually to the car, because otherwise, if you're going to SSH from cellular data, you're going to have to mess with forwarding ports on your router in order for your Raspberry Pi to be accessible outside of your home network. So that's what I've actually done here. So I'm set up for that. You likely are not. So I would recommend the first option of using a Wi-Fi dongle or bringing it physically with you. Now, you could also just leave it inside of your house. When you do that, you have to have an antenna so that the signal is going to be strong enough for the car to receive it from your house to wherever your car is. Now, an antenna is fairly simple to build. In my case, what I've done is I've taken an iPhone charger that no longer works, and I've stripped it and cut off both ends, and I've taken 2 of the wires that are inside and tied them together. Now, that's a very rudimentary antenna, and it works. So you don't need anything more fancy than literally just a copper wire. And you would connect that to the GPIO 4 pin on your Raspberry Pi. Now, it's important to note that when you do this, if you connect an antenna to your GPIO 4 pin, your transmission pin on your Raspberry Pi, and you transmit on that, there's no filter. So your signal is going to be, you could call it dirty, and it's going to splash stray radio signals all over the spectrum. And like we covered before, you don't want to be transmitting in places that you aren't supposed to be, because that's generally frowned upon. So you would use a pass filter between the antenna and the GPIO 4 pin in order to mitigate that. But, do whatever you want. So what I'm going to do is I am going to go outside, and we are going to be issuing a few commands. And I will tell you those here because you will not be able to see me SSH while we're outside. So I'll be right back with those commands. All right, so I'm going to show you issuing the command from my PC inside my house, and so you can see which command is run and how it works. After that, I will take a stroll outside and show you issuing the command remotely from my phone to the Raspberry Pi with an antenna connected, of course, using the pass filter to avoid transmitting in places you're not supposed to be, obviously. So you're going to want to cd into the RPITX directory. Once you've done that, we need to send the signal that we recorded. In this case, it is unlockcar.iq right there. So we do that by issuing the following command: sudo /send iq space -s250000 space -f, and then your frequency that you recorded on without the decimal point. So -f space, in my case it is 314.817. Whoops, without the decimal point, 314.817. After that, you're going to do E6 again, and then -T U8 space -I, and this is going to be your file name, and mine is unlockcar.iq. Now, once we issue this command, the Raspberry Pi will use the RPITX software to transmit that command over the GPIO 4 pin to your car. Your car will receive that signal. And now, since we've recorded the signal not in range of the car, that code has not been burned. So when I issue this command, I'm using an antenna, so my car will actually unlock while I'm out here, but I will do it again when we're outside. So I'm going to issue it now. It looks like our sample rate is 2. Oh, there we go. So my car should be unlocked outside as we speak. I'm going to take a step out and I will show you guys the command from outside. So here we are, and I'm going to go ahead and SSH into my Raspberry Pi remotely and issue that same command that we talked about in order to unlock the car. One moment here. And you should see pretty soon the car will unlock. There we go. And that's it. So here we are back. Now that you've seen it in action, that something like this works, you should be aware that it is completely legal to do this to your own car. It's not a big deal, but what you should not be doing is you should not be doing this to other people's cars or cars that you do not own. That is a given. You will get in trouble for that. Now, with that out of the way, on newer cars, fancier cars like Teslas, Mercedes, Range Rovers, and things like that, they feature proximity sensors where the key fob, when you are near the car will unlock, and you only have to have the key in your pocket in order to unlock the car or even start the car with the push button presses. They actually make pre-made devices for that. Again, you shouldn't own one of those because obviously that's against the law. But it's even easier than that. You can buy these off of eBay and Amazon and things like that. And people in larger cities, Detroit, LA, New York, can walk up to your house with this device, and since your key is transmitting, sitting on your counter after you set it there, after you got home from work and went to bed, they can essentially do the same thing that we did here, except with the push of one button. Now, they own your car after that. So they can walk right up to your Tesla. Tesla recognizes that it is your key because they've copied, again, the transmission, and they can open your door and they can drive right off with your car. And that's why it's so important to, like everything else, take proper security measures to secure your belongings. They make little pockets, little pouches for your keys that you can put them in when you get home or when you're not using them, that basically act as a Faraday cage, and that they block any signals going in or out. So your key signal cannot be copied. So while this crime is common, it's not the most common. So use that information and do your own research as to what is going on in your area. There's likely bigger things to worry about than people stealing your Tesla. So, with that said, review this information, learn from it, and see you next time.